So let's record a little bit of our introduction to proof. Section 3.2, number 36. I need to write down what we're trying to prove. Not 36, number 28. Try that again. It says, prove that if A, B, and BA are both defined, then AB and BA are both square matrices. Okay, this is a very good one to kind of start the idea of proof, I think. So what I'm going to write up here is what I'm given. What am I given? Not a whole lot. Well, you're given the hypothesis, the part that comes after the if, right? So I'm given A, B, and BA are both defined. Okay, that's what I'm given. Now, if I'm successful in this proof, what's going to be the very last statement of the proof? It's going to be something like, therefore, what? Yeah, AB and BA are both square matrices. And it's funny because when mathematicians work on proofs, we tend to work backwards. At least most people that I know do. They'll tend to look at what you're trying to prove. And this is that step that I mentioned last time called unpacking. What I mean by that is, and this is not a common phrase for it, but basically, I'm going to write down what this means. It's almost like when you do when you do word problems in algebra class, the hard part is translating the words into a mathematical statement. So that's what I want to do here. I have some language. What does it mean for these things to be square matrices? Can you guys say what that means?
It's a matrix of an equal number of rows and columns.
Yeah.
And the product of two square matrices must also be a square.
Yeah, so it's like the step before this ought to say something like A, B, and BA have the same number of rows and columns. Right? It's important to know, that's why I talk about this class being a foreign language class. You know, you have to know what all the definitions are of all these different things. That's what we mean by square matrices. Now let's go up top and unpack the given information. And let's just focus on one of them. If we know that AB is defined, what does that mean?
A has the same number of columns as B has rows.
Right. Right. So if AB is defined, suppose the dimensions of A, no, let's not write it that way. It's just a little bit too casual. Suppose that A has, we usually use the letter M rows, right? And N columns, right? Then because AB is defined, it must be that B has what? For AB to be defined, let's look at it carefully, right? We're saying that this one here is M by N, right? So what do we know about matrix B? That's my question. Well, it has to be N times something, right? Because for this to be defined, it must be that B has N what? N rows. Because AB is defined. You guys with me? But now, if you look at this product also being defined, and we're saying B is N by something, right? And what are we saying about A? We're saying it's M by N. Do you see how the logic works now? What does this tell us? So also, B must have what? Do you see it or no? Maybe no. Do you guys agree? That's the only way that BA would be defined, is if those inner numbers match. So B must have M columns because BA is defined. This implies that AB is what size matrix? Well, I can see the ends match up. I just learned that that question mark is actually what? So AB is going to be M by M, and BA is what? N by N. I agree. I agree. And so you kind of just continue the logic. I think we're done, right? AB and BA have the same number of rows and columns. Therefore, AB and BA are both square matrices. See how that worked? I mean, I think it's interesting. You want to write down both what you're given and what you're trying to prove and kind of unpack it and then see if you can get from one to the other. And I really think that especially looking at what you're trying to prove is a useful idea when it comes to trying to do proofs. You see that?